Take everything you think exists in the universe, every star, every planet, every galaxy, every living thing, and gather it into a single pile. Then look at how much empty space is left over. You would find that almost nothing is there. If the cosmos were shrunk to the size of an ocean, all the matter within it would amount to less than a single drop. We are taught that the universe is full of stars, galaxies, light, and life. The truth is the opposite. The universe is overwhelmingly, relentlessly, almost perfectly empty, and the closer you look, the emptier it becomes. This is why the more powerful our telescopes grow, the more hollow the cosmos reveals itself to be, until we are forced to confront a possibility that unsettles even the scientists who study it for a living. The emptiness is not an accident. It is a feature, and it may be the single most important reason we are here at all. Before we begin, be sure to like the video and subscribe for more journeys into the cosmos. Now, take a deep breath and let's begin. Hold up your hand in front of your face. Between your fingers and your eyes, there is a small gap of air, and that air feels like nothing at all. But it is not nothing. A single breath contains more molecules than there are stars in every galaxy we have ever mapped. That is how full the world around you is. Now imagine leaving it behind. Imagine rising up through the atmosphere, watching the blue thin out into black, until the last wisps of air fall away beneath you. The higher you climb, the emptier space becomes, and it happens faster than you would ever expect. At the altitude where the International Space Station orbits, the air is already so thin that a human lung could not draw a single useful breath from it. Keep climbing. By the time you pass the orbit of the Moon, roughly 384,000 kilometers away, the density of matter around you has collapsed to almost nothing. And you have not even left your own backyard. Begin with the thin shell of air that keeps you alive, because even that is a lesson in how little separates us from the emptiness. The atmosphere feels vast when you look up at the sky, an endless dome of blue reaching to the heavens. But it is not vast at all. If the Earth were shrunk to the size of an apple, the entire breathable atmosphere would be thinner than the apple's skin. The blue you see is a fragile film, a few dozen kilometers deep, clinging to the surface of the planet. Climb just a little way above it, and the air thins to nothing. The sky darkens to black, and the emptiness of space begins. Everything you have ever breathed, every cloud you have ever watched drift by, every bird that has ever flown, exists within that impossibly thin layer. Beyond it, immediately, is the vacuum, pressing against the fragile skin of air from every direction, held back only by the planet's gravity. We do not live surrounded by emptiness at a safe distance. We live right at its edge, separated from the void by nothing more than a thin breath of gas. Consider what emptiness truly means, because our everyday words fail us here. When you stand in a room that feels empty, it is still packed with air, with roughly 25,000 billion molecules in every single liter around you. That is not emptiness. That is a dense, crowded, jostling crowd of particles, bumping into each other billions of times every second. The best vacuum that human engineers have ever created in a laboratory, the emptiest space we can manufacture on Earth, still contains hundreds of thousands of molecules in every cubic centimeter. And yet the space between the planets is far emptier than that. The space between the stars is emptier still, and the great cosmic voids are emptier than anything we could ever hope to build, regions where you might sweep out a volume the size of a house and find only a handful of lonely atoms drifting through it. When astronomers say empty, they mean something so close to true nothingness that our instruments strain to detect any matter there at all. The Moon is our closest companion in space, And even it teaches the lesson of emptiness. It hangs in the sky looking close enough to touch, a familiar face that has watched over our world for billions of years. But it is far more distant than it appears. The gap between the Earth and the Moon is so wide that you could fit every other planet in the solar system into the space between them, lined up side by side, and still have room to spare. All the worlds of the solar system tucked neatly into the emptiness between us and our nearest neighbor. And the Moon is close. It is the one other world humans have ever set foot upon, reached after only 3 days of travel. Everything beyond it lies vastly further, across gulfs of emptiness that dwarf the already enormous distance to the Moon. If even our nearest neighbor sits across a gap that could swallow every planet in the solar system, imagine the emptiness that lies beyond. Let us return to our own star for a moment, because even here, in the one place where matter gathers thickly, the emptiness has already begun its quiet reign. The Sun is a sphere of glowing gas so large that more than 1 million bodies the size of Earth could fit inside it. Its surface seethes at nearly 6,000 degrees. Its core, where hydrogen fuses into helium, burns at roughly 15 million degrees, hot enough to crush atoms together against their will and release the light that warms your face. The Sun is the most substantial, most massive, most crowded thing for light years in any direction. And yet, even the Sun is mostly the very lightest elements, hydrogen and helium, spread across a volume so enormous that its average density is not much greater than water. Beyond its glowing edge, the emptiness resumes immediately, and it does not stop. The influence of the Sun reaches outward, through the thin stream of particles it constantly breathes into space. The solar wind, a whisper of charged matter racing outward at hundreds of kilometers per second. But even this wind is so thin that by the time it passes Earth, there are only a few particles in every cubic centimeter. A density that would count as a near-perfect vacuum in any laboratory on the planet. Our star deserves a closer look, because it is the one great concentration of matter in our immediate cosmic neighborhood, and even it is dwarfed by the emptiness around it. The Sun is so large that more than 1 million Earths could fit inside it. It is so massive that it holds the entire solar system in its gravitational grip, steering the planets in their orbits across billions of kilometers of empty space. Every second, deep in its core, it converts millions of tons of matter into pure energy, releasing more power in a single second than human civilization has produced in its entire history. And yet, for all this staggering scale and power, the Sun is an utterly ordinary star, one of 400 billion in our galaxy, and far from the largest among them. There are stars so enormous that if one replaced the Sun, it would swallow the orbits of the inner planets entirely, its surface reaching out past where the Earth now travels. Against such giants, our Sun is modest. And against the emptiness of the galaxy, even the largest stars are tiny points of light, separated by distances so vast that light itself needs years to cross from one to the next. Here is the first thing that should quietly unsettle you. The solar system, the place we call home, the collection of 8 planets and countless moons and asteroids and comets, is almost entirely empty. If you could stand at the center, at our star, and look outward, you would see nothing in every direction for an unimaginable distance. The Sun holds 99.86% of all the mass in the solar system. Everything else, every planet, every moon, every mountain and ocean and living thing is a rounding error scattered in the leftover space, and that space is vast beyond comprehension. The distance from the Sun to Earth is about 150 million kilometers. Light, the fastest thing that exists, moving at just under 300,000 kilometers every second. Takes over 8 minutes to cross that gap. But Earth is close. Earth is practically hugging the star. To reach Neptune, the outermost planet, that same light needs more than 4 hours. And beyond Neptune, the emptiness only deepens. Think about what that actually means. If you built a scale model of the solar system and made the sun the size of a large beach ball, Earth would be a grain of pepper 26 meters away. Jupiter, the giant of our system, would be a marble more than 100 meters distant. And Neptune would be a tiny speck almost 800 meters from the beach ball, a full 10-minute walk away. In between all of these, there would be nothing. No matter how carefully you searched, the space between the planets would be almost perfectly, hauntingly empty. We picture the solar system as a busy place, full of orbiting worlds and swirling asteroid belts. The reality is that if you were dropped into a random point inside the solar system, the odds of you being anywhere near anything at all would be effectively zero. You would float in blackness, the sun a bright point in the distance, and everything else lost in the dark. The planets themselves are strung out along their orbits like beads on wires of vastly different lengths. Mercury huddles close to the star, scorched and airless. Venus follows, wrapped in a suffocating blanket of cloud. Then Earth, then Mars, and beyond Mars, a gap widens, filled with the scattered rubble of the asteroid belt. We often picture that belt as a treacherous field of tumbling boulders. The reality is that the average distance between one asteroid and the next is close to 1,000,000 kilometers. If you were standing on a typical asteroid, you would see only empty black sky, with perhaps a faint, moving point of light if you were lucky enough to catch a neighbor at all. Every spacecraft humanity has ever sent outward through that belt has passed through it without incident, because there is simply so little there to hit. The belt is not a wall. It is a rumor of matter, spread so thinly that crossing it is like walking across a continent and expecting to bump into another person by pure chance. Now let us go further, because the emptiness is only getting started. Beyond Neptune lies a region called the Kuiper Belt, a ring of icy bodies where Pluto drifts, along with thousands of frozen worlds. You might imagine it like the asteroid fields in films, a dense swarm of tumbling rocks you would have to dodge. The truth is almost funny. The objects in the Kuiper Belt are so far apart that if you were standing on one of them, the nearest neighbor would likely be millions of kilometers away, far too distant to see with the naked eye. Spacecraft have flown straight through both the asteroid belt and the Kuiper Belt without ever coming close to hitting anything. The chance of a random collision is so small that engineers do not even seriously worry about it. The belts are not walls of rock. They are ghostly, thin scatterings of debris, spread across volumes of space, so enormous that the matter inside them practically vanishes. Past the giant planets, Jupiter and Saturn with their swirling storms and delicate rings, past the pale ice giants Uranus and Neptune, the sunlight grows faint and blue and cold. Out here, the sun is still the brightest thing in the sky, but it no longer feels like a source of warmth. It is a brilliant point, a diamond on black velvet, casting long, weak shadows across frozen worlds. Neptune takes 165 Earth years to complete a single orbit. A person born on the day Neptune was discovered would have to wait an entire long human lifetime to see the planet return to the same spot in the sky. That is how slowly the outer solar system turns, and how vast the distances have become. And Neptune is not the edge. Neptune is merely where the familiar planets end and the true frontier of emptiness begins. And still we have barely moved. Beyond the Kuiper Belt lies the true edge of the sun's influence, a distant shell of icy bodies called the Oort cloud. This is where the emptiness becomes almost impossible to hold in your mind. The Oort cloud may stretch as far as 100,000 times the distance between Earth and the Sun. Light from our star, which crossed to Earth in 8 minutes, would take more than a year to reach the outer edge of this frozen shell. And within that colossal sphere, the comets are so widely separated that each one drifts alone, kilometers upon kilometers of nothing in every direction, a solitary iceberg in an ocean with no water and no shore. If you stood on one of these distant comets and looked back toward home, the Sun would be just another star, a slightly brighter point among the thousands scattered across the black. You would not be able to tell, with your eyes alone, that this was the star that gave you life. The comets of the outer solar system are among the loneliest objects imaginable. Each one is a small mountain of ice and dust, perhaps a few kilometers across, tumbling slowly through the dark. Most of them will never come anywhere near the Sun. They will spend the entire age of the solar system, billions upon billions of years, drifting in the frozen outer dark, never warming, never changing, never encountering another object. Occasionally, once in many thousands of years, the faint gravitational nudge of a passing star will tug one of these icy wanderers loose and send it falling inward toward the Sun. Only then, as it warms and begins to glow and grow a tail, do we finally see it, a brief, bright visitor streaking across our sky before it plunges back into the outer dark, not to return for 1,000 human lifetimes. For every comet we ever see, there are countless others we never will, drifting silently in the emptiness, unseen and unknown, from the birth of the solar system to its end. To feel the emptiness, it helps to see what the opposite extreme looks like. Scattered through the galaxy are the collapsed corpses of massive stars, objects so dense they defy imagination. A neutron star is the crushed core left behind when a giant star exhausts its fuel and collapses, packing more mass than the entire Sun into a sphere no larger than a city. On such a star, matter is squeezed so tightly that a single spoonful would weigh as much as a mountain. The contrast could not be sharper. On one hand, the cosmic voids, so empty that a volume the size of a house might hold only a handful of atoms. On the other, the crushed heart of a dead star, where a spoonful outweighs a mountain range. Between these two extremes lies everything else, and almost all of it, by overwhelming measure, sits far closer to the emptiness than to the crush. The dense objects are the rare exceptions, tiny knots of impossibly concentrated matter, lost in a cosmos that is mostly nothing at all. So we leave the solar system entirely. We cross the invisible boundary where the Sun's wind gives way to the wind of other stars, and we enter interstellar space. Here, the emptiness reaches a scale that breaks the human imagination. The nearest star to our Sun is Proxima Centauri. It sits about 4.2 light-years away. That means light. Moving at nearly 300,000 kilometers per second takes 4.2 years to make the journey. Written out in kilometers, that distance is roughly 40,000 billion kilometers of almost perfect nothing between us and the closest star in the entire universe. Let that settle. The closest one. It is worth dwelling on the nearest star because it stands as the true measure of interstellar loneliness. The closest star to our Sun is a small, dim, red one, far too faint to see with the naked eye despite being our nearest neighbor. It sits about 4 light-years away, which sounds almost manageable until you translate it into something the mind can feel. The gap between our Sun and that nearest star is roughly 7,000 times wider than the entire span of our planetary system, from the Sun all the way out to the most distant planets. Cross the whole solar system, from edge to edge, and you would have covered only a tiny fraction of the way to the closest star. And that closest star is unusually close. Most stars in our part of the galaxy are further from their neighbors still, each one an isolated island of fire, separated from every other by gulfs of emptiness so wide that the fastest thing in existence needs years to cross them. The night sky looks crowded with stars, but that is an illusion born of their brilliance. In truth, they are scattered so thinly through the dark that the emptiness between them is the overwhelming reality. When we finally leave the sun behind and cross into the space between the stars, we enter a realm that is almost inconceivably vast and almost perfectly empty. The material that fills interstellar space is called the interstellar medium, and it is the thinnest gas imaginable. In the average patch of space between the stars, there is roughly one atom in every cubic centimeter. One atom. In a volume the size of a sugar cube. Compare that to the air you are breathing, with its tens of billions of molecules in the same tiny space, and you begin to feel the true scale of the emptiness. To gather a single gram of interstellar gas, you would have to sweep clean a volume of space larger than the entire Earth. And yet, spread across the enormous distances between the stars, even this ghostly thin gas adds up. It is from clouds of exactly this material, slowly drawn together by gravity over millions of years, that new stars are eventually born. The emptiness is not entirely barren. It is the nursery from which the next generation of stars will one day emerge. We have sent a few small emissaries out into that interstellar emptiness, and their journeys reveal its scale better than any number could. The most distant human-made objects are a pair of spacecraft launched in the 1970s, now drifting beyond the edge of the sun's influence into true interstellar space. They are the fastest departing objects we have ever built, racing outward at more than 60,000 kilometers per hour. And yet, at that tremendous speed, they have been traveling for nearly half a century, and they have covered only a tiny fraction of the distance to the nearest star. If one of them were headed toward the nearest star, which it is not, it would take roughly 70,000 years to arrive. 70,000 years, at more than 60,000 kilometers per hour, just to reach the closest star in the entire cosmos. That is the true measure of interstellar emptiness. Our fastest ships, given the whole span of human civilization to work with, could barely begin to cross it. To grasp this, shrink the sun down until it is the size of a single grain of sand. On that scale, where our entire star is smaller than a poppy seed, the nearest neighboring grain of sand, Proxima Centauri, would be roughly 6 kilometers away. 2 grains of sand, 6 kilometers of empty space between them. And that is a typical spacing for stars in our part of the galaxy. We look up at the night sky, and it seems crowded, a dome sprinkled thick with stars. But that crowding is an illusion, created by distance. In reality, the stars are almost unbelievably far apart. Tiny islands of matter drowning in oceans of vacuum, so wide that light itself grows weary crossing them. If 2 galaxies passed straight through one another, something that genuinely happens, the odds of any single star colliding with another are so low that in most cases not one direct hit would occur. The galaxies would slide through each other like 2 swarms of fireflies crossing in the night, and almost nothing would touch. There are places where the interstellar gas gathers more thickly, cold, dark clouds of dust and molecules, where the light of background stars is blotted out entirely. These are the star-forming regions, the great stellar nurseries, and even they are far emptier than anything we would call empty on Earth. Inside one of these dense clouds, the gas might reach a density of a few 100,000 molecules per cubic centimeter, which sounds like a lot until you remember that ordinary air holds tens of billions of billions. By earthly standards, the densest star-forming cloud in the galaxy is a better vacuum than anything our finest machines can produce. And yet, given enough time and enough gravity, even this whisper of matter can collapse. Over hundreds of thousands of years, the densest knots within these clouds draw inward, growing hotter and denser at their centers, until at last the core ignites and a new star begins to shine. From the thinnest emptiness, given time, the universe builds its lights. This is the first great lesson of the cosmos. Space is not mostly empty. Space is almost entirely empty, and the tiny fraction that contains anything at all is spread so thin that calling it rare does not begin to capture it. But here is where the story deepens and where it starts to become strange. Because that emptiness is not random. It is structured. If you could pull back far enough to see the whole observable universe at once, you would not see stars scattered evenly like grains of salt on a table. You would see something that looks almost alive. Let us take a journey outward, not in kilometers, but in the time it takes light to travel, because that is the only honest way to feel these distances. Light is the fastest thing that exists, crossing nearly 300,000 kilometers in a single second. At that speed, a beam of light could circle the entire Earth more than 7 times in one heartbeat. Now let it leave the Earth and race outward. It reaches the Moon in a little over 1 second. It reaches the Sun in 8 minutes. It passes Jupiter in about 43 minutes and Neptune in more than 4 hours. Already, in crossing our own tiny solar system, light has spent hours of travel, and it has passed almost nothing the entire way, only the thin, scattered planets and the vast dark between them. Let the beam continue outward, past the last planets, past the frozen comets of the outer dark, and into the space between the stars. Now the pace slows to a crawl against the emptiness. It takes light more than 4 years to reach the very nearest star. 4 years of racing through perfect vacuum at a speed that could circle the Earth 7 times a second just to reach our closest neighbor. To cross from one side of our galaxy to the other, that same beam of light would need 100,000 years. 100,000 years of unbroken travel, passing through the thin, scattered stars of the Milky Way, most of the journey through empty space to cross a single galaxy. And the Milky Way is only one of 2 trillion. Let the beam of light leave our galaxy entirely and strike out across the space between the galaxies. To reach the nearest large galaxy, Andromeda, it must travel for 2.5 million years. The light entering your eyes from Andromeda tonight, that faint smudge visible on a dark, clear night, left that galaxy 2.5 million years ago, long before our own species existed. You are not seeing Andromeda as it is. You are seeing it as it was, in a past so distant that no human had yet walked the Earth. And Andromeda is our close companion, one of the nearest galaxies of all. To reach the more distant galaxies, the light must travel for hundreds of millions, or billions, of years, crossing gulfs of intergalactic emptiness so vast that the journey consumes a significant fraction of the entire age of the universe. This is why looking out into space is always looking back into time. The further away something is, the longer its light has traveled to reach us, and the older the image we see. When we point our most powerful telescopes at the most distant galaxies, we are seeing light that left them more than 13 billion years ago, when the universe itself was young and the first galaxies were only beginning to form. We are looking across such enormous stretches of emptiness that we are seeing the deep past, the infancy of the cosmos, captured in ancient light that has been crossing the void ever since. Every point of light in a deep telescope image is a message from the distant past, carried across an ocean of emptiness so wide that the message took billions of years to arrive. We cannot see the universe as it is now. We can only see it as it was, layered by distance into a vast archive of cosmic history, written in light and separated by emptiness. Now, expand your view to take in the whole of the Milky Way, our home galaxy. It is a vast, spinning disk of stars, gas, and dust, stretching roughly 100,000 light-years from edge to edge. Within it turns something like 400 billion stars, along with immense clouds of gas and the invisible weight of dark matter that holds the whole structure together. From within, we see it as a faint band of light arching across a dark sky. The combined glow of countless distant suns, too far away to resolve as individual points. And even here, in the crowded heart of a great galaxy, the stars are almost unimaginably far apart. Our own sun sits in a fairly quiet suburb of the galaxy, about halfway out from the center. The nearest stars to us are separated by distances so great that a beam of light, the fastest thing in existence, needs years to cross from one to the next. If you shrank the sun to the size of a grain of sand, its nearest stellar neighbor would be another grain of sand kilometers away, with nothing but empty vacuum in between. The galaxy is not a solid mass of stars. It is a vast, thin, sparkling mist, mostly made of the darkness between its lights. Nothing in the cosmos sits still, and our own motion through the emptiness is dizzying to contemplate. Right now, without feeling a thing, you are being carried through space at tremendous speed. The Earth spins on its axis, and it races around the Sun at more than 100,000 kilometers per hour. The Sun, in turn, carries the entire solar system around the center of the galaxy at hundreds of thousands of kilometers per hour, on a journey so vast that a single orbit takes more than 200 million years. The last time the Sun was in its current position in the galaxy, dinosaurs had not yet appeared on Earth, and the galaxy itself is moving, drifting through the cosmic web, drawn toward distant concentrations of mass across hundreds of millions of light-years. We are never still. We are always moving, always being carried through the vast emptiness, on a journey with no destination and no end, riding a small, warm world through the cold and silent dark. At the very center of the Milky Way lies something that concentrates the emptiness into its opposite. A supermassive black hole, more than 4 million times the mass of the Sun, crushed into a region of space that would fit comfortably inside the orbit of Mercury. Around it, stars whip in tight, fast orbits, moving at millions of kilometers per hour, bent by a gravity so extreme that not even light can escape from beyond a certain edge. This is the still point around which the entire galaxy turns. And yet, even here, in the most crowded and violent neighborhood in the galaxy, the vast majority of the space is empty. The stars near the center are packed more densely than anywhere else, and still they are separated by distances that light takes weeks or months to cross. The black hole itself, for all its unfathomable mass, occupies a region tiny compared to the emptiness surrounding it. The center of the galaxy is not full. It is simply slightly less empty than everywhere else. Beyond the Milky Way, the emptiness opens into a scale that dwarfs everything we have described so far. Our galaxy is not alone. It belongs to a small gathering of galaxies called the Local Group, bound together by gravity across a few million light-years. The largest member besides our own is the Andromeda Galaxy, a spiral even grander than the Milky Way, drifting toward us through the dark. In roughly 4 billion years, Andromeda and the Milky Way will meet and merge, their stars sweeping through one another over hundreds of millions of years. And here is the astonishing thing. When these two enormous galaxies collide, containing perhaps 1 trillion stars between them. Almost none of those stars will actually strike each other. The distances between the stars are so vast, and the stars themselves so tiny by comparison, that the two galaxies will pass through one another like two clouds of smoke, mingling and reshaping without a single direct collision in most scenarios. The galaxies will merge, but the stars will barely notice. That is how empty even a galaxy is. Zoom out past the stars, past the swirling disk of the Milky Way with its 400 billion suns, past our neighboring galaxies, past the local cluster, out to the scale where entire galaxies become single glowing points. At that scale, a pattern emerges that stunned astronomers when they first mapped it. The galaxies are not spread out uniformly. They are strung together along immense glowing threads, filaments of light stretching for hundreds of millions of light years. These threads cross and weave and meet at dense knots where thousands of galaxies gather. And between the threads lie the voids, enormous, silent, almost perfectly empty bubbles of space. Scientists call this structure the cosmic web, and once you have seen it, you can never unsee it. The universe, at the largest scale we can observe, looks like a vast, three-dimensional net. The bright strands are made of galaxies and gas, drawn together over billions of years by gravity. And the dark spaces between them, the voids, are where the true emptiness lives. These voids are not small. A typical cosmic void can stretch across 100 million light-years or more. Inside one, you might travel for tens of millions of light-years and encounter almost nothing. No galaxies, no stars, just the faintest whisper of thin gas and the invisible presence of something we do not fully understand. The voids make up the overwhelming majority of the volume of the universe. If you picked a random point anywhere in the cosmos and dropped down into it, you would almost certainly find yourself floating in one of these great empty bubbles. With the nearest galaxy so far away, it would be little more than a faint smudge if you could see it at all. Take a moment to feel the shape of this. The universe is not a sea of stars with a few gaps. It is a sea of gaps with a few threads of stars laced through it. The bright, warm, living places, the galaxies, the star nurseries, the worlds like ours, cling to the thin filaments of the cosmic web like dew clinging to a spider's silk. Everything we have ever known, every human who has ever lived, every creature that has ever breathed, exists on one strand of that web, in one galaxy, in one small corner. And all around us, in every direction, the voids stretch outward, patient and enormous, and utterly indifferent. This is the unsettling part. Not that the universe is empty, but that the emptiness has a design. Pull back further, and the local group itself shrinks to a single point among many. Galaxies gather into clusters, clusters gather into superclusters, and superclusters trace out the shining filaments of the cosmic web. Our local group sits on the outskirts of a vast structure, drawn slowly toward a great concentration of mass called the Great Attractor, and beyond that, toward an even larger assembly of galaxies. But between these bright gatherings lie the voids, and the voids are where most of the volume of the universe actually is. A single large void can be 100 million light-years across or more, and inside it, matter is so sparse that a galaxy might drift alone for 100 million light-years in every direction, with no bright neighbor anywhere close. There are galaxies out there, deep inside the great voids, that are so isolated they may have no companions at all, within a distance that light itself takes tens of millions of years to cross. Imagine being born on a world in such a galaxy, looking up at a night sky that holds only your own stars, with nothing but perfect darkness in every direction beyond them. For those isolated galaxies, the emptiness is not a distant abstraction. It is the entire sky, Our own place in the cosmic web is worth understanding too. The Milky Way and its companions belong to the local group, which sits at the edge of a much larger structure. We are part of a great flattened supercluster of galaxies. And beyond that, we are being drawn slowly toward an even more enormous concentration of mass. Careful mapping of the motions of thousands of galaxies has revealed that our local group is part of a vast flowing structure, a basin of attraction stretching across hundreds of millions of light years, all of it slowly draining toward a common center. Astronomers gave this immense structure a name that captures its scale, calling it a supercluster, large enough to contain 100,000 galaxies. And even this titanic structure is just one feature of the cosmic web, one bright knot among countless others, surrounded on all sides by the great voids. We are not at the center of anything. We are a small galaxy in a small group, riding the currents of a vast structure we are only beginning to map, adrift in a cosmos whose true scale we can barely hold in mind. Where the filaments of the cosmic web cross and gather, the universe builds its greatest cities of light. These are the galaxy clusters, immense assemblies of hundreds or thousands of galaxies, bound together by gravity into the densest structures in all the cosmos. Within a great cluster, galaxies swarm and jostle, occasionally colliding and merging, their combined gravity so strong that it bends the very fabric of space around them. The space between the galaxies in a cluster is filled with thin, superheated gas, glowing faintly in wavelengths our eyes cannot see, hotter than the interior of any star, yet so sparse it would count as a vacuum on Earth. These clusters are the exception, the rare dense knots where matter has gathered most thickly. And even they are surrounded, on every side, by the great voids, the empty regions that make up most of the volume of the universe. The clusters shine because they are rare. The emptiness dominates because it is the rule. Between the brightest cities of the cosmos stretch the vast, dark countrysides of nothing, larger by far than everything they contain. The largest structures ever mapped in the universe stretch the mind past its limits. Astronomers have found immense walls of galaxies, sheets of matter, thousands of galaxies thick, stretching across the sky for staggering distances. One such structure, a great wall of galaxies, extends across a span that would take light more than 1 billion years to cross. These are the densest threads of the cosmic web, the brightest strands of the great foam. And wrapped around them, in every direction, are the voids, the enormous empty bubbles that make up most of the volume of everything. The bright walls, for all their vast extent, are still just the thin surfaces of the bubbles. Most of the universe, by far, is the empty interior, the great dark hollows where almost nothing exists. The walls are impressive precisely because they are the exception, the rare places where matter has gathered thickly enough to shine. It is worth understanding just how empty a cosmic void really is. In an average region of the universe, galaxies are separated by a few million light years, and clusters of galaxies gather in the dense knots of the web. Inside a great void, the density of galaxies drops to a small fraction of that. A galaxy inside a void might have no significant neighbor for 100 million light years in any direction. If you lived on a world in such a galaxy and you looked up at your night sky, you would see the stars of your own galaxy, and beyond them, almost nothing. No neighboring galaxies scattered across the dark, as we see from our own more crowded corner. Only your own island of stars, and then the empty black, stretching outward past the reach of any telescope you could ever build. Such galaxies exist. They are out there right now, drifting in the great voids, more alone than anything we can easily imagine. Deep inside a great cosmic void, the conditions are stranger than anywhere else in the universe. Here, gravity has almost nothing to pull on, and dark energy reigns almost unopposed. The few galaxies that exist within a void are being pushed apart faster than galaxies anywhere else, carried outward by the relentless expansion of the nearly empty space around them. These void galaxies tend to be smaller and quieter than their crowded cousins in the dense filaments of the web. They form stars more slowly, undisturbed by the collisions and close encounters that stir up galaxies in richer environments. In a way, they are the most peaceful places in the universe, drifting alone through the great dark hollows, forming their stars in undisturbed calm. But that peace comes at the price of profound isolation. A void galaxy may have no significant neighbor for 100 million light-years, and as the void continues to expand, that isolation only deepens with time. If there are minds in such galaxies, looking up at their empty skies, they inhabit a loneliness on a scale that our own crowded corner of the cosmos can barely suggest. Even the emptiest regions of space are not perfectly empty, and what little they contain tells a story. The vast spaces between the galaxies are threaded with an incredibly thin gas, so sparse that it makes the space between the stars seem crowded by comparison. In the deepest intergalactic voids, there may be only a single atom in a volume the size of a small room, or even less. This is a vacuum so profound that no machine on Earth could ever reproduce it, an emptiness that makes our finest laboratory vacuums look dense and cluttered. And yet this whisper, thin gas, spread across the enormous volumes between the galaxies, actually contains a significant portion of all the ordinary matter in the universe. The emptiness is so vast that even matter spread almost infinitely thin adds up to a great deal when you account for all the space it fills. Most of the ordinary matter in the cosmos is not locked up in stars and planets at all. It drifts, unseen, as thin gas in the great spaces between the galaxies. A diffuse haze filling the emptiness, invisible and almost immeasurably sparse. So why is it built this way? Why threads and voids? Why not a smooth, even glow of matter, spread gently across all of space? The answer takes us back to the very beginning, to a moment less than 1 second after the universe began. In that first instant, the cosmos was almost perfectly uniform, a searing hot fog of energy and particles filling every point of a rapidly expanding space. Almost perfectly uniform, but not quite. There were tiny ripples in that fog, minuscule differences in density, some regions holding a fraction more matter than others. These ripples were unimaginably small, differences of perhaps 1 part in 100,000, and yet those faint imperfections were the seeds of everything. Gravity is patient, and gravity is relentless. In the regions that started with a little extra matter, gravity pulled a little harder. More matter flowed in. Those regions grew denser, which made their gravity stronger still, which pulled in even more matter, in a slow feedback that unfolded across billions of years. And in the regions that started slightly emptier, the opposite happened. Matter drained away toward the denser neighbors, leaving the empty places emptier still. Over cosmic time, the tiny ripples grew into a vast contrast. The dense regions collapsed into galaxies and clusters and the shining filaments of the web. The empty regions expanded and hollowed out into the great voids. The universe sorted itself, over billions of years, into somewhere and nowhere. And the nowhere won by an overwhelming margin. There is a famous experiment that captures the true scale of the cosmos better than any number. Astronomers once pointed a powerful telescope at a patch of sky that appeared completely empty, a dark spot no larger than a grain of sand held at arm's length, chosen precisely because it seemed to contain nothing at all. They held the telescope on that empty patch for days, gathering the faintest trickle of light. And when the image finally resolved, that tiny speck of apparently empty sky was found to contain thousands of galaxies, each one holding hundreds of billions of stars, stretching back billions of years into the depths of cosmic time. Thousands of galaxies, in a patch of sky that looked utterly empty to the naked eye. Multiply that across the entire sky, and the number of galaxies climbs into the trillions. This is the strange dual nature of the cosmos. It is overwhelmingly empty, and yet it is also unimaginably full, packed with more galaxies and stars and worlds than any mind can hold, all of it scattered across an emptiness so vast that even this abundance is spread impossibly thin. The numbers that describe the cosmos climb so high, so fast, that our minds simply lose their footing. There are more stars in the observable universe than there are grains of sand on every beach and in every desert on Earth. Not close to as many. Many times more. If you tried to count them, one every second, without stopping to eat or sleep, you would not finish in a human lifetime, or 1,000 human lifetimes, or the entire history of our species. You would still be counting long after the sun had swollen into a red giant and swallowed the earth. And every one of those countless stars is separated from its neighbors by vast gulfs of emptiness, each one a lonely island of fire in an ocean of dark. The mind reaches for these numbers and slides off them. They are simply too large to hold. And that inability to grasp them is itself a lesson. A reminder that the cosmos operates on a scale that human intuition was never built to comprehend. The discovery of these voids was one of the great surprises of modern astronomy. For a long time, scientists assumed that if you zoomed out far enough, the universe would look smooth, with galaxies sprinkled more or less evenly in every direction. Then, in the late 1970s and early 1980s, astronomers began carefully mapping the three-dimensional positions of thousands of galaxies. What they found astonished them. The galaxies were not spread out evenly at all. They clumped together along sheets and threads, leaving behind enormous empty regions where almost no galaxies existed. One of the first great voids they discovered, in the direction of the constellation Boides, was so large and so empty that it seemed almost impossible. It stretched across nearly 300 million light-years, and within that colossal volume, there were barely any galaxies at all. The universe, it turned out, was not a smooth soup. It was a foam, full of bubbles, and the bubbles were the emptiness. The discovery of the cosmic web unfolded slowly across decades of painstaking work. For most of human history, we did not even know that other galaxies existed. The faint smudges we now call galaxies were once thought to be clouds of gas within our own Milky Way. It was only about a century ago, in the 1920s, that astronomers proved these smudges were entire separate galaxies, island universes of their own. At distances so vast, they staggered the scientists who first measured them. And it was only in the following decades that we began to understand how those galaxies were arranged. At first, the universe seemed to be filled with galaxies scattered more or less at random. Then, as astronomers mapped their three-dimensional positions with ever greater care, the true structure emerged, the walls and filaments and voids of the cosmic web. Each new survey revealed the pattern more clearly until there could be no doubt. The universe was a foam, and the emptiness was its dominant feature. The discovery that the universe is expanding is one of the great turning points in human understanding. A century ago, most scientists assumed the universe was static, eternal, and unchanging, the same yesterday as today and forever. Then astronomers noticed something strange in the light of distant galaxies. The light was shifted toward the red end of the spectrum, and the further away a galaxy was, the greater the shift. The only sensible explanation was that the galaxies were all receding from us, and that the space between them was stretching. Run that expansion backward, and everything must once have been packed together in a hot, dense beginning nearly 14 billion years ago. This single insight, drawn from the reddened light of distant galaxies, overturned the ancient belief in an eternal, changeless cosmos and replaced it with a universe that had a beginning, a history, and a future. The emptiness we see, the great gulfs between the galaxies, are the visible record of that expansion, growing wider with every passing moment as the universe continues to stretch. One of the most important tools in revealing this structure was the study of how galaxies move. Because the universe is expanding, distant galaxies are all receding from us, and the light they emit is stretched to longer, redder wavelengths as it crosses the expanding space. The further away a galaxy is, the faster it recedes, and the more its light is shifted toward the red. By measuring this shift, astronomers can calculate how far away each galaxy is and build a three-dimensional map of the cosmos. When they did this for hundreds of thousands of galaxies, the cosmic web appeared in stunning detail, its filaments and voids traced out across billions of light-years. The maps looked less like a random scattering of points and more like a vast neural network or the branching structure of a living thing. The universe, at the largest scales, has a shape, and that shape is mostly holes. There is a hard limit to how much of the emptiness we can ever see, and it is worth understanding. Because light travels at a finite speed, and because the universe has existed for a finite time, we can only see objects whose light has had time to reach us since the beginning. This defines a boundary, a horizon, beyond which lies space we cannot observe, not because nothing is there, but because its light has not yet arrived and, in many cases, never will. The observable universe, the sphere of space from which light has reached us, is already staggeringly large, stretching tens of billions of light-years in every direction. And yet it is almost certainly only a small portion of the whole. Beyond our horizon, the universe very likely continues, filled with more galaxies, more filaments, and more of the same vast emptiness, extending far past anything we can ever detect. Some evidence even suggests the true universe may be many times larger than the part we can see, or perhaps without limit at all. The emptiness we observe, enormous as it is, may be only a tiny sample of an emptiness so vast that it has no edge and no end, stretching on forever beyond the reach of any telescope we could ever build. There is a name for the invisible hand behind much of this shaping: dark matter. We cannot see it. It emits no light, reflects no light, and passes straight through ordinary matter as though it were not there. And yet it outweighs everything we can see by a factor of more than 5 to 1. For every kilogram of ordinary matter in the universe, the stuff that makes stars and planets and people, there are more than 5 kilograms of this invisible substance. We know it exists because we can feel its gravity. Galaxies spin far too fast to hold themselves together with the gravity of their visible stars alone. Something unseen is holding them, a vast halo of dark matter cradling each galaxy like an invisible hand. To understand how this foam came to be, we have to look at the faint afterglow of the beginning itself. Everywhere we look in the sky, in every direction, there is a faint hiss of microwave radiation, the cooled remnant of the fireball that filled the universe when it was young. This is the cosmic microwave background, and it is a photograph of the cosmos as it was less than 400,000 years after the Big Bang, long before any stars or galaxies existed. When astronomers measured it with exquisite precision, they found it to be almost perfectly smooth. The same temperature in every direction to within 1 part in 100,000. Almost perfectly smooth, but not quite. There were tiny variations, minuscule hot and cold spots, differences of a few parts in a million. Those tiny ripples are the fingerprints of the future. The slightly denser regions, the faint cold spots, were the seeds that would grow over billions of years into galaxies and clusters and the shining filaments of the web. And the slightly sparser regions, the faint warm spots, were destined to hollow out into the great voids. The entire structure of the cosmos, all the somewhere and all the nowhere, was written into that faint afterglow when the universe was still an infant. There is something almost miraculous about how smooth the early universe was. When we measure the faint afterglow of the beginning, the cosmic microwave background, we find it to be astonishingly uniform. In every direction we look, across the entire sky, the temperature of that ancient light is almost exactly the same, matching to within a few parts in 100,000. This smoothness is strange, because regions on opposite sides of the sky are so far apart that light could never have traveled between them in the age of the universe. They should never have been able to reach the same temperature, and yet they have. The leading explanation is that in the very first instant of existence, the universe underwent a burst of expansion so sudden and so extreme that a tiny, uniform patch was stretched to cosmic scales in a fraction of a second. That single burst smoothed out the young cosmos and, at the same time, stretched the tiny quantum ripples within it into the seeds of galaxies. The emptiness we see today, the great smooth voids, may trace their origin all the way back to that first violent instant of stretching, when the universe was smaller than an atom and expanding faster than thought. When astronomers run their most powerful simulations of the young universe, feeding in the tiny ripples from the beginning and letting dark matter's gravity do its work, something remarkable happens. The web appears on its own. The dark matter flows and collapses, forming exactly the same pattern of filaments and voids that we see in the real sky. The ordinary matter, the gas that will become stars, simply falls in afterward, following the invisible scaffolding the dark matter has already built. We are, in a very real sense, living inside a structure sculpted by something we cannot see, following blueprints laid down in the first fraction of a second of time. The bright galaxies are just the visible frosting on a vast, dark, unseen cake. The first stars to shine in the universe were unlike anything that exists today. For a long stretch after the beginning, the cosmos was dark, filled with nothing but cooling gas, with no stars and no light of any kind. This era is sometimes called the Cosmic Dark Ages, a time when the universe held matter but no shining thing to light it. Then, in the densest regions of the primordial gas, gravity gathered enough material to ignite the first stars. These first stars were giants, far larger than most stars today, blazing with fierce blue-white light and burning through their fuel in only a few million years. When they exhausted themselves, they exploded, scattering the first heavy elements, the first carbon and oxygen and iron, out into the surrounding emptiness. Before those first stars, the universe contained only the lightest elements, hydrogen and helium, and nothing from which a planet or a living thing could ever be built. The first stars ended the darkness, and they seeded the emptiness with the raw material of everything that would come after. Every heavier atom in your body traces its lineage back to stars like these, the first lights to break the long primordial dark. This expanding emptiness has a beginning we can actually trace. By measuring how fast the universe is expanding today and running the process backward, astronomers can calculate how long ago everything was packed together. The answer is about 13.8 billion years. At that moment, the entire observable universe, all 2 trillion galaxies worth of matter and energy, was compressed into a state of unimaginable density and heat. From that beginning, space itself began to expand, and it has been expanding ever since, growing from something smaller than an atom into the vast, mostly empty cosmos we inhabit today. The emptiness we see around us is the direct result of that expansion. The universe is empty in large part because it has been growing relentlessly for nearly 14 billion years, stretching the same matter across an ever larger volume of space. The longer the expansion continues, the emptier the universe becomes, as the same fixed amount of matter is spread ever more thinly across an ever-growing void. In the very early universe, there were no voids and no filaments, no galaxies and no stars. There was only a nearly uniform sea of hot gas, filling all of space with almost perfect smoothness. The tiny ripples in that gas, the faint variations in density we can still read in the cosmic microwave background, were the only seeds of structure that existed. But those seeds were enough. Gravity took the slightly denser regions and pulled them together, slowly, over hundreds of millions of years, until the first stars ignited in the collapsing gas. Those first stars were enormous, brilliant, and short-lived, blazing through their fuel in only a few million years before exploding and scattering the first heavy elements into the surrounding emptiness. From the ashes of those first stars, new stars formed and gathered into the first small galaxies, which merged and grew into the great galaxies we see today. The entire luminous cosmos, every star and galaxy that has ever shone, grew from those first faint ripples in the primordial gas, sculpted by gravity out of near-uniform emptiness into the intricate web we now observe. But the voids are not merely empty, because matter drained away from them. Something else is pushing them wider, forcing them to grow, driving them ever emptier. And this something is the deepest mystery in all of physics. We call it dark energy. In dense regions, full of galaxies and dark matter, gravity still rules. It pulls things together, holding clusters bound across billions of years. But inside the voids, where matter is scarce, gravity has almost nothing to grip. And there, a different force takes over. Dark energy is a strange, invisible pressure woven into the fabric of empty space itself. The more empty space there is, the more of it there is. And it does not pull. It pushes. What drove those tiny ripples into the vast structures we see today was gravity, working with almost unimaginable patience across almost unimaginable time. But gravity alone, acting on the ordinary matter we can see, could never have built the cosmic web fast enough. There simply was not enough time, and not enough visible matter, for gravity to gather the galaxies into the patterns we observe. Something else had to be there from the beginning, providing extra gravity, an invisible scaffolding around which the ordinary matter could gather. That something is dark matter, and the cosmic web is one of the strongest pieces of evidence that it truly exists. When scientists build vast computer simulations of the young universe and include only the ordinary matter, the results do not match the sky. But when they add dark matter, feeding in 5 times as much invisible mass as visible mass, the simulations bloom into exactly the pattern we see. The same filaments, the same clusters, the same enormous voids. We cannot see the dark matter, but we can see the shape it carved into the cosmos, and that shape is written across the entire sky. Here is the discovery that shook cosmology to its foundations. For most of the 20th century, scientists assumed the expansion of the universe was slowing down. The Big Bang flung everything outward, and gravity, they reasoned, should be gently applying the brakes, pulling everything back together, slowing the great expansion over time. Then, in the late 1990s, two teams of astronomers set out to measure exactly how much the expansion was slowing. They studied distant, exploding stars, using them as cosmic mile markers across billions of light years, and they found the opposite of what they expected. The expansion was not slowing down. It was speeding up. Something was pushing the universe apart faster and faster with every passing moment, and no known force could explain it. It is worth pausing to feel how strange this is. The universe is built, in large part, out of a substance we have never directly detected, that gives off no light, that passes through walls and planets and our own bodies without leaving a trace. Right now, as you sit reading this, dark matter particles are almost certainly streaming through you, through the chair beneath you, through the earth under your feet, as though none of it were there at all. They do not bounce off the atoms in your body. They do not warm you or push you or leave any mark. They simply pass through, felt only through the faint tug of their gravity across enormous scales. And yet this ghostly, invisible substance outweighs all the stars and planets and gas in the universe by more than 5 to 1. The bright, visible cosmos, everything we can see with every telescope we have ever built, is only a thin, luminous skin stretched over a vast, invisible skeleton. The emptiness is not truly empty, even where it seems most so. It is filled with a darkness we can feel but never see. That something is dark energy, and it makes up roughly 68% of everything in the universe. Sit with that number. 68% of the entire cosmos is a form of energy we cannot see, cannot touch, and cannot explain, a pressure hidden in the emptiness that is tearing the universe apart. Add in the 27% that is dark matter, the invisible scaffolding, and you find that only about 5% of the universe is made of ordinary matter. 5%. Everything you have ever seen, every star that has ever shone, every atom in your body, belongs to that thin 5%. The other 95% is dark, unseen, and profoundly mysterious. The universe is not just empty of matter. It is dominated by things we barely understand, and they live in the emptiness. The expansion of the universe itself is worth pausing on, because it is stranger than it first sounds. When we say the universe is expanding, we do not mean that the galaxies are flying apart through space, like fragments from an explosion racing outward into a pre-existing void. We mean that space itself is stretching, growing, expanding between the galaxies. The galaxies are not moving through space so much as being carried apart by the swelling of space between them. Imagine dots on the surface of a balloon that is slowly being inflated. The dots do not move across the surface, and yet they all grow further apart, because the surface between them is stretching. That is what the galaxies are doing. They ride on the fabric of space, and as that fabric expands, they drift apart. Not because they are traveling, but because the emptiness between them is growing. This is why distant galaxies can recede faster than light, something no object traveling through space could ever do. It is not the galaxies that move too fast. It is the space itself that expands, without limit, carrying everything within it along. Now the voids take on a new and stranger character. They are not passive. They are engines. Inside each great void, dark energy pushes outward with almost no gravity to resist it. The void swells. As it swells, it grows even emptier, which gives dark energy even more room to push, which makes the void swell faster still. The voids are inflating like bubbles in cosmic dough, and as they grow, they press against the filaments around them, squeezing the galaxies together onto ever thinner threads. The emptiness is not just spreading, it is winning. With every passing billion years, the voids grow larger, and the bright web grows more isolated, more stretched, more alone. This is where we arrive at the truly unsettling picture of our future. Because the expansion is accelerating, distant galaxies are receding from us faster and faster. And there comes a point, at a certain distance, where a galaxy is moving away so quickly that its light can no longer ever reach us. It crosses a boundary called the cosmic horizon, and once it is gone forever. Not hidden, not far. Simply unreachable, cut off from us by the expansion of space itself, forever beyond the edge of anything we can ever observe or ever visit. And this horizon is shrinking inward. One by one, over the vast stretch of future time, the distant galaxies will slip across it and vanish from our sky. And then there is dark energy, which is stranger still, and which turns the emptiness from a passive backdrop into an active force. For most of cosmic history, gravity was winning. The expansion that began in the Big Bang was gradually slowing, as the mutual pull of all the matter in the universe applied a gentle brake. Had that continued, the universe might eventually have slowed, stopped, and begun to fall back together. But roughly 6 billion years ago, something shifted. The expansion stopped slowing down and began to speed up. A mysterious pressure, woven into the fabric of empty space itself, had begun to dominate, pushing the universe apart faster and faster. We call it dark energy, and it is the single largest component of the cosmos, making up more than 2/3 of everything that exists. The more the universe expands, the more empty space there is, and the more empty space there is, the more dark energy there is to push it apart. It is a runaway process, and it means the emptiness is not just growing, it is accelerating. Run the clock forward far enough, and the picture becomes lonely beyond words. In the very distant future, perhaps 100 billion years from now, every galaxy outside our own local group will have receded beyond the horizon. The night sky, to any beings that might exist then, will contain only the stars of their own merged galaxy. The rest of the universe will have vanished, pushed away by dark energy until its light can never again cross the widening gulf. Those future astronomers, if they exist, will look out and see a single island of stars surrounded by perfect, endless black. They will have no way to know that 100 billion other galaxies once filled the sky. They will have no way to discover the expansion, no way to find the cosmic web, no way to learn the true history of the cosmos. The evidence itself will have been carried away into the emptiness. We are living, right now, in a rare and precious window when the universe is still legible, when the light of distant galaxies still reaches us, and the story is still written across the sky. That window is closing. But let us come back from that distant future to a question that sits much closer to home. If the universe is this empty, this vast, this thoroughly dominated by voids and dark forces, then where does that leave us? And here we arrive at the strangest twist of all. The emptiness is not our enemy. The emptiness may be the very reason we exist. To understand why, we have to ask a question that sounds almost too simple. Why is the universe the size it is? Why is it so old, so vast, so spread out? Why not a small, cozy, crowded cosmos packed with stars close together? The answer reveals a chain of delicate balances so fine that changing any one of them by the smallest amount would erase us completely. This is where the future of the universe becomes genuinely haunting. If dark energy continues as it appears to be, the acceleration will never stop. The voids will keep growing, the filaments will keep stretching, and the galaxies beyond our local neighborhood will keep receding from us faster and faster. There will come a time, many billions of years from now, when the light of those distant galaxies can no longer reach us at all. They will not have moved away in the ordinary sense. The space between us and them will simply be stretching faster than their light can cross it. One by one, the distant galaxies will fade and redden and vanish, slipping over the cosmic horizon into a place from which no signal can ever return. The observable universe, which today contains perhaps 2 trillion galaxies, will shrink and shrink until only our own merged local group remains, a single island of light, adrift in an ocean of perfect, expanding dark. Start with time. The atoms in your body were not present at the beginning of the universe. The hydrogen was, but the carbon, the oxygen, the nitrogen, the iron in your blood, none of these existed in the first moments of the cosmos. They were forged inside stars, deep in the cores of massive suns. Over millions of years, simple hydrogen was fused into heavier and heavier elements, building the carbon and oxygen that life requires. And when those massive stars reached the end of their lives, they exploded, scattering these newly minted elements out into space. Those explosions seeded the emptiness with the raw material of planets and people. It took generations of stars, living and fading across billions of years, to enrich the cosmos with enough heavy elements to build a world like Earth and a creature like you. You are, quite literally, made of the ashes of ancient stars. Imagine the astronomers of that distant era, should any exist. They will look out at their night sky and see only the stars of their own galaxy, a single, luminous island with nothing beyond it. The rest of the universe will have vanished, carried away by the expansion until not one distant galaxy remains visible. They will have no way to know that the cosmos was ever anything more than their single island of stars. The evidence of the Big Bang, the faint afterglow that we can still detect today, will have stretched and faded until it too becomes undetectable. The expansion itself will be impossible for them to discover, because there will be nothing left in their sky moving away from them to reveal it. They will conclude, quite reasonably, that they live in a small, static, eternal universe surrounded by endless, empty dark. And they will be wrong, but they will have no way to know it. We are living in a rare and fleeting golden age of cosmology, a brief window in cosmic history when the universe is still young enough and still full enough to be understood. Future minds will inherit an emptier sky and a poorer view, and the truth we can see today will have slipped forever beyond their reach. Yet even at the height of this cosmic construction, the emptiness was never truly conquered. As galaxies formed and gathered along the filaments of the web, the regions between the filaments were drained of matter, growing emptier as the filaments grew denser. The voids were not left behind by the construction. They were created by it. Every galaxy that formed along a bright filament represented matter that had flowed out of the surrounding regions, leaving those regions emptier than before. The building of structure and the emptying of the voids were two halves of the same process, driven by the same patient gravity across the same billions of years. The universe did not fill up with matter over time. It sorted itself, gathering matter into the thin, bright web and emptying out the vast, dark spaces in between. The more structure formed, the emptier the emptiness became. So the emptiness is not static. It is spreading, and in the deep future it will win completely. The stars will burn out, one by one, over trillions of years, as the gas that feeds new star formation is finally exhausted. The last stars to shine will be the small, cool, red ones, sipping their fuel so slowly that they can burn for trillions of years. But even they will eventually fade. The galaxies will dim from brilliant spirals to dark scatterings of cold, dead remnants, cooling ash and silent stellar corpses drifting in the growing dark. Over spans of time so long that the current age of the universe is barely a rounding error against them, Even the black holes will slowly evaporate, radiating away their mass into the emptiness until nothing remains but a thin, cold, ever-thinning haze of particles spreading forever into the dark. This is the ultimate fate. The emptiness promises not a bang, not a crunch, but a long, slow, quiet, fading into a darkness deeper than anything the universe has ever known. To understand the future of the emptiness, we must stretch our sense of time past the breaking point. The universe is about 14 billion years old, and that already feels like an eternity. But the future, the emptiness, promises unfolds on timescales that make 14 billion years seem like an instant. The smallest, longest-lived stars will continue to shine not for billions, but for trillions of years, sipping their fuel so slowly that they will outlast every bright star in the sky many times over. After the last stars fade, the universe will drift on, dark and cold, for spans of time so long that the numbers require towers of zeros to write. Dead stars will slowly wander, galaxies will slowly dissolve, and the great black holes will slowly evaporate, each process taking unimaginably longer than the last. Against these timescales, the entire age of the universe so far, all of cosmic history from the beginning until now, is less than the first tick of an endless clock. We live at the very dawn of time, in the bright, brief morning of a cosmos whose long, cold afternoon and endless night lie almost entirely ahead. We can even predict how this process will end, far into the future. And the prediction is sobering. As the expansion accelerates under the push of dark energy, the voids will grow larger and the filaments will stretch thinner. The galaxies bound together by gravity, like our own local group, will remain bound, eventually merging into single great galaxies. But everything beyond those bound groups will recede over the horizon and vanish from view. Star formation will slow and then cease, as the gas that feeds new stars is used up or blown away. The existing stars will burn through their fuel and fade, the brilliant ones first, then the sun-like ones, and finally, over trillions of years, even the small, dim red stars that burn the slowest of all. The galaxies will darken from bright spirals into cold scatterings of dead remnants, drifting in an ever emptier dark. The universe will not end in fire or in a great collapse. It will end in cold and in emptiness, fading slowly toward a silence deeper than anything that has ever been. Not everything will be carried away by the accelerating expansion, and this offers a strange kind of comfort. Structures that are held together tightly enough by gravity will resist the expansion and remain bound. Our own galaxy, and the small group of galaxies to which it belongs, are gravitationally bound, and they will stay together even as the rest of the universe recedes beyond reach. In the distant future, the Milky Way and its large neighbor Andromeda will merge into a single great galaxy, and the other members of our local group will join them, forming one large island of stars. That island will remain, held together by gravity, long after every other galaxy has vanished over the cosmic horizon. So the far future is not one of total dissolution, at least not for a very long time. It is one of profound isolation, in which each bound group of galaxies becomes an island unto itself, surrounded by an ever-growing ocean of empty, expanding dark, with no other island visible anywhere in the sky. The emptiness does not tear apart what gravity holds tightly. It simply carries everything else away, until each surviving island is utterly alone. On timescales so vast, they defy imagination, even the remnants will disappear. The dead stars, the cooling embers, the frozen worlds will slowly be broken apart by rare gravitational encounters, flung out of their galaxies into the growing void. The great black holes at the centers of galaxies, having swallowed what they can, will themselves begin to evaporate, radiating their mass away particle by particle over spans of time so long that every number we know becomes meaningless against them. At the very end of this process, there will be nothing left but a thin, cold, ever-thinning haze of particles and radiation, spreading forever into an infinite and expanding dark. No stars, no galaxies, no structure of any kind, only the emptiness, complete at last, having reclaimed everything the universe ever built. This is the ultimate destiny that dark energy and expansion seem to promise, a future of perfect emptiness, arrived at not through catastrophe but through the slow, quiet, patient spreading of everything into nothing. Now here's the point. That process takes time, an enormous amount of time. Billions of years of stars being born, living, and scattering their elements before a planet like ours could even form. And then billions more for life to emerge and evolve into something that could look up and wonder. A universe that was small and short-lived, one that expanded briefly and then collapsed back on itself, would never last long enough for any of this to happen. The stars would not have time to build the heavy elements. The planets would never form. Life would never begin. For a universe to produce observers, it must be old. And to be old while expanding, it must be vast. And to be vast, it must be overwhelmingly empty. The emptiness is the price of time, and time is the price of us. It goes deeper still, into the fundamental settings of physics themselves. Consider the strength of gravity, or the amount of dark energy woven into empty space. If dark energy were even slightly stronger than it is, its outward push would have overwhelmed gravity long ago in the early universe. Space would have flown apart so fast that matter could never have clumped together at all. No galaxies, no stars, no planets, just a thin, cold, expanding fog of particles growing ever more distant forever. The emptiness would have been total and permanent and lifeless. It is worth stating plainly because it never loses its power. The iron in your blood was forged in the heart of a dying star. The calcium in your bones was cooked in stellar furnaces and scattered across space by ancient explosions. The oxygen you breathe, the carbon that forms the backbone of every molecule in your body, all of it was manufactured inside stars that lived and faded long before the sun was born. For billions of years, those atoms drifted through the emptiness, part of the thin gas between the stars, waiting. Then gravity gathered them, along with countless others, into the cloud that collapsed to form our solar system. They became the Earth and the oceans. And eventually, through the long, slow chemistry of life, they became you. You are not separate from the stars. You are made of them, literally, atom by atom, assembled out of the scattered ashes of the cosmos into a form that can look up at the night sky and recognize, with a shock of wonder, its own distant origin. And if dark energy were slightly weaker, or if it pushed inward instead of out, gravity would have won too soon. The universe would have expanded briefly, then reversed, collapsing back into a searing crunch before stars ever had time to build the elements of life. The window between too much push and too much pull is astonishingly narrow. The measured value of dark energy is so finely balanced that, by some estimates, if you changed it by an amount far smaller than we can easily write, the universe would be sterile, either torn apart before it could form anything, or crushed before anything could live. We exist in the narrow crack between two catastrophes, in a universe tuned, somehow, to allow the slow, patient work of stars and time and life. This delicate tuning appears again and again, in setting after setting. The strength of the force that binds atomic nuclei, the mass of the tiny particles that make up matter, the balance between the forces that push atoms apart and the forces that hold them together. Adjust almost any of these by a hair, and the universe becomes barren. Stars fail to ignite or burn out in an instant. Carbon never forms. Water never exists. The recipe for a living cosmos is written on a knife's edge, and we find ourselves, improbably, on exactly the right side of every blade. Scientists have a name for this puzzle. They call it the fine-tuning problem, and it is one of the deepest and most argued questions in all of physics. Why does the universe appear so precisely arranged to allow complexity, chemistry, and life? There are several ways people try to answer it, and each one is stranger than the last. The first answer is the simplest. Perhaps it is pure chance. Perhaps we simply happen to live in a universe with the right settings, and there is nothing more to say. But to many scientists, the odds feel too extreme, the tuning too precise, for chance alone to feel satisfying. So they reach for a second answer. And this is where the emptiness returns in a form more staggering than anything we have yet imagined. What if our universe is not the only one? What if the Big Bang that created our cosmos was just one event among countless others? What if space is far larger than the part we can see? So vast that it contains an endless number of separate universes, each one born with its own random settings, its own strength of gravity, its own amount of dark energy? This is the idea of the multiverse. In most of those universes, the settings would be wrong, dark energy too strong, and they tear apart before anything forms, gravity too weak, and no stars ever ignite. The vast majority would be empty, sterile, and lifeless, expanding or collapsing into nothing without a single witness. But in a rare few, purely by chance, the settings would land in the narrow habitable range. And in those rare few, stars would form, and planets would gather, and life would eventually arise to look up and ask why the universe seems so perfectly suited to its existence. Let us make the fine-tuning concrete, because in the abstract, it is easy to dismiss. The stars shine because, deep in their cores, hydrogen fuses into helium, releasing energy in a chain of nuclear reactions. This process depends on the precise strength of the force that binds atomic nuclei together. If that force were slightly stronger, hydrogen would have fused too easily in the early universe, burning away before stars could form, leaving a cosmos with no long-lived stars at all. If it were slightly weaker, the crucial reactions that build heavier elements would fail, and the universe would be left with almost nothing but hydrogen, forever. Either way, no carbon, no oxygen, no chemistry rich enough for life. The window in which stars can shine steadily for billions of years, forging the elements of life along the way, is astonishingly narrow, and our universe sits squarely inside it. Change the setting by a small amount in either direction, and the cosmos becomes barren, either a quick flash of fusion or an eternal cold fog of hydrogen, with nothing in between. The formation of carbon itself, the element on which all known life is built, depends on a coincidence so precise that it once astonished the scientists who discovered it. Carbon is forged inside stars when 3 helium nuclei come together, but the odds of 3 particles meeting at exactly the same instant are vanishingly small. The only reason carbon forms in significant amounts is that a particular energy level inside the carbon nucleus happens to line up almost perfectly with the energy of the colliding particles, dramatically boosting the reaction. This alignment was predicted before it was found, precisely because carbon exists in abundance, and therefore some such coincidence had to be true. Had that energy level been positioned even slightly differently, carbon would be rare, and the universe would hold little of the element that makes life possible. The recipe for a living cosmos depends on details, this fine, buried deep in the structure of atomic nuclei, tuned somehow to allow the slow, patient chemistry of life to unfold. We do not know why these details fall where they do. We know only that, had they fallen elsewhere, we would not be here to ask. Do you see the twist? If there are countless universes with random settings, then it is no surprise at all that we find ourselves in a fine-tuned one. We could not possibly exist in any of the others. The barren universes have no one in them to notice how barren they are. Only the rare, finely balanced universes ever produce observers. And so, of course, every observer who ever wonders about the tuning finds themselves in a tuned universe. It could not be otherwise. This is called the anthropic principle, and it turns the fine-tuning puzzle inside out. We do not live in a special universe because someone arranged it for us. We live in a special universe because it is the only kind that could ever contain a someone to live in it. And the emptiness is central to the whole idea. Because for a multiverse to work, for enough universes to exist that a habitable one becomes likely, space must be almost unfathomably larger than the part we can see. Beyond our cosmic horizon, past the edge of everything our telescopes can ever reach, space may stretch on, not for billions of light years, but for distances so vast that the numbers lose all meaning. Some theories suggest the universe may be truly infinite, and an infinite universe carries a consequence that is difficult to even speak aloud. In an infinite space, filled with an endless number of stars and worlds, every possible arrangement of matter would occur, not once, but an infinite number of times. Somewhere out there, unreachably far, there would be another world exactly like Earth. Another version of you, reading these exact words, in a room exactly like the one you are in now. Not one copy, infinitely many. Scattered across an emptiness so enormous that you will never, ever reach a single one of them. The idea that our universe might be one among countless others is not merely idle speculation. It emerges naturally from some of our deepest theories about how the cosmos began. If the burst of expansion that smoothed our early universe was not a single event but an ongoing process, then it may still be happening somewhere, endlessly spawning new regions of space, each one becoming its own universe with its own settings. In such a picture, our entire observable cosmos, all 2 trillion galaxies of it, would be just one bubble among an unending froth of bubbles, each sealed off from the others by unimaginable gulfs of expanding space. Most of those bubble universes would have settings that forbid complexity and would remain forever empty of any observer. A rare few would land, by chance, in the narrow range that permits stars and chemistry and life. We would necessarily find ourselves in one of those rare few because we could exist nowhere else. The emptiness within our own universe would then be dwarfed by an even greater emptiness beyond it. The vast, unreachable spaces separating our bubble from all the others, a silence so complete that no signal could ever cross it. This is why the emptiness matters so profoundly. The vastness, the voids, the endless dark spaces are not evidence that the universe is barren and meaningless. They may be evidence that the universe is so large, so full of possibility, that our own improbable existence becomes not just possible, but inevitable. The emptiness gives room for the dice to be rolled enough times that, somewhere, they were bound to land on us. We are the improbable outcome of an unimaginable number of throws, and the empty space is the vast table across which those throws are scattered. But there is a colder way to read all of this, and honesty demands we face it. If we truly are just one accidental success among a near infinity of failures, then the emptiness carries no comfort at all. It means we are not special in any cosmic sense. It means the universe was not made for us, was not tuned for us, does not know we are here, and will not notice when we are gone. The voids do not care. The dark energy does not care. The expansion will continue, patient and relentless, carrying the galaxies apart long after the last star has burned out. And, in the deep future, the universe will return to the emptiness from which it came, colder and darker and more silent than it has ever been. We are a brief flicker of warmth in an ocean of cold, a moment of light that the darkness will eventually reclaim. And yet, there is another way to hold this truth, and it is the one worth carrying with you. Consider how staggeringly unlikely you are. For you to exist, the universe had to be born with settings balanced on a razor's edge. Stars had to live and fade for billions of years to forge the atoms in your body. A void-filled cosmos had to expand for just the right amount of time, in just the right way, to give those atoms the chance to gather into a world, and then into life, and then into a mind capable of understanding any of this at all. Against an emptiness so total that most of the universe holds nothing whatsoever, you happened. The atoms that make you could have remained scattered forever across the dark filaments of the cosmic web. Instead, for a brief and precious moment, they came together into something that can look up at the emptiness and comprehend it. That is not nothing. In a universe that is almost entirely empty, you are one of the rarest things that exists. It is natural to find this future bleak, and it would be dishonest to pretend otherwise, but it is worth remembering how far away it lies. The timescales involved are so enormous that the entire history of the universe so far, all 13.8 billion years of it, is an eye blink by comparison. The stars will continue to shine for trillions of years yet. The universe, as we know it, full of galaxies and light and possibility, is not in its old age. It is in its youth, or at most its early middle years, with vast stretches of luminous time still ahead. We live near the beginning of the story, not the end, in an era when the cosmos is still rich with structure and light, still legible, still full of stars. The emptiness will win in the end, but the end is unimaginably far away. For now, and for a very long time to come, the universe remains a place of light and warmth and wonder, and we are lucky beyond measure to be here to witness it. There is a subtle and beautiful point hidden in all of this. The universe is not merely a place that happens to contain observers. The conditions that make it observable, the vastness, the age, the emptiness, the slow forging of the elements, are the very same conditions that make it capable of producing observers in the first place. A universe simple enough to be easily grasped, small enough to feel cozy, would be a universe too poor to produce a mind capable of grasping anything. The complexity that overwhelms us is the same complexity that made us. The emptiness that dwarfs us is the same emptiness that gave us room to exist. We are not accidental intruders in a cosmos indifferent to our presence. We are a natural, if rare, product of exactly the kind of universe we find ourselves in, a universe old enough and vast enough and empty enough to eventually give rise to something that could look back and understand. The difficulty of comprehending the cosmos and the possibility of comprehending it at all are two sides of the same deep fact. Let us return, one last time, to the scale of it all, and let the emptiness wash over you completely. Our galaxy, the Milky Way, contains something like 400 billion stars, and it is one of perhaps 2 trillion galaxies in the observable universe. 2 trillion galaxies, each holding hundreds of billions of stars, and around many of those stars, worlds beyond counting. The numbers are so large they stop meaning anything. And yet, spread across the true volume of space, all of that matter, every galaxy, every star, every planet, amounts to almost nothing. If you smoothed out all the ordinary matter in the universe evenly across all of space, the average density would come to just a few atoms per cubic meter. A few atoms. In a volume the size of a small room, you would find fewer particles of ordinary matter than you could count on your fingers. That is the true face of the cosmos. That is what full looks like. When you finally see it clearly, there is a deep question that the emptiness forces upon us, one that scientists and philosophers have wrestled with for a long time. Why is there something rather than nothing at all? The universe did not have to exist. There is no obvious reason why anything should exist rather than an eternal, perfect, featureless nothing. And yet, against whatever odds we might imagine, there is something. There is space and time and matter and energy, and out of these, over billions of years, arose stars and worlds and life and minds. The emptiness is vast, but it is not total. Scattered through it, rare and precious, is everything that exists, including the awareness that can pose this very question. We may never know why there is something rather than nothing, but we can marvel that there is, and that we are part of it, briefly, against the odds. In a cosmos that is mostly dark, set your own life against this backdrop, and something shifts in how you see it. You occupy a single small world, orbiting an ordinary star, in a quiet suburb of one galaxy among 2 trillion. The light from the nearest galaxy beyond our own left its source before our species existed. The light from the most distant galaxies has been traveling since the universe was young, crossing gulfs of emptiness for billions of years to reach your eyes. And you, a temporary arrangement of ancient stardust, are here to receive it, to gather that ancient light and, from it, to reconstruct the history of the entire cosmos. There is something almost absurd about this, that a small, warm creature on a small, warm world could come to understand the vast, cold emptiness that surrounds it. And yet we have measured the distances, traced the expansion, mapped the web, and weighed the darkness. The emptiness is enormous, and we are tiny. And still, against all reasonable expectation, we have found a way to comprehend it. It is tempting to ask whether we are alone in all this emptiness, and the question deserves a careful answer. The universe is enormous, containing perhaps 2 trillion galaxies, each with hundreds of billions of stars, and around many of those stars, planets by the countless billion. The sheer number of worlds is so vast that it seems almost impossible that life arose only once, only here. And yet the emptiness works against us. The distances between the stars are so great that even if life is common, even if intelligent civilizations arise on distant worlds, the gulf of empty space between them may be too vast ever to cross, or even to signal across in any reasonable time. A message sent at the speed of light from the far side of our own galaxy would take 100,000 years to arrive. A message to the nearest large galaxy would take millions of years. The emptiness does not merely separate the stars. It may isolate every living world that ever exists, each one an island of awareness surrounded by a sea of silence too wide to ever fully bridge. When we turn our instruments outward and listen for other minds in the emptiness, what we hear, so far, is silence. For decades, we have scanned the sky for any signal, any deliberate transmission, any hint that some other civilization is out there, sharing the vast dark with us. We have heard nothing. This silence might mean many things. Perhaps life is rare, and the emptiness truly is as empty of minds as it appears. Perhaps life is common, but the distances are so vast that no signal has yet had time to reach us across the intervening void. Perhaps other civilizations are out there right now, separated from us by gulfs of emptiness so wide that we will never hear them, and they will never hear us, each of us alone on our own small island in the dark. Whatever the truth, the silence is itself a kind of teacher. It reminds us how vast the emptiness is, how thinly any life must be scattered across it, and how precious the small, warm pocket of awareness on our own world truly is, whether or not it has any company anywhere in all that dark. The emptiness also puts our human concerns into a strange and useful perspective. Every human being who has ever lived, every empire that has risen and fallen, every triumph and tragedy of our entire history, has taken place on a single small world, orbiting a single ordinary star, in a quiet corner of one galaxy among 2 trillion. Seen from far enough away, the Earth is not even a point of light. It is nothing, a mote too small and too dim to detect against the emptiness. And yet everything that has ever mattered to any human being has happened there. The vastness does not make our lives meaningless. If anything, it makes them more precious because they are so rare, so improbable, so fleeting against the enormous dark. In a universe that is almost entirely empty and almost entirely indifferent, the small, warm world where we love and struggle and wonder is a treasure beyond price, precisely because there is so little like it anywhere else. There is a way to make the emptiness of an atom felt, and it changes how you see every solid object around you. Everything you have ever touched, the desk, the floor, your own skin, is made of atoms, and atoms are almost entirely empty space. At the center of each atom sits a tiny, dense nucleus, and around it, at a great distance by comparison, drift the electrons. If you could enlarge a single atom until its nucleus was the size of a marble placed at the center of a large stadium, the electrons would be tiny specks whirling around the very outermost seats, and everything in between would be empty. That is not a special atom. That is every atom. The chair you are sitting on, the ground beneath you, the mountains and oceans of the entire planet are all more than 99.9% empty space by volume. The solidity you feel is an illusion produced by forces between particles that are themselves separated by relative gulfs of nothing. Emptiness is not just the character of the cosmos on the largest scales. It is the character of matter itself, all the way down. So the emptiness reaches from the very smallest scales to the very largest, and everywhere in between. The inside of every atom is mostly empty. The space between atoms in a gas is mostly empty. The space between planets is emptier still, and the space between stars emptier than that, and the great voids between galaxies, the emptiest of all. At every scale you choose to examine, the same truth reappears. The stuff of the universe, the actual matter, is rare, scattered, and precious, drowning in oceans of nothing that dwarf it at every level. We are made of the rare stuff, gathered against enormous odds into the shape of a world and the shape of a life. But the rare stuff has always been the exception. The emptiness is, and always has been, the overwhelming rule. Consider how quiet the universe is, in every sense of that word. Sound cannot travel through the vacuum of space, because sound needs matter to carry it, and space has almost no matter to carry anything. If a star exploded a few light years from Earth, an event releasing more energy in a moment than the sun will produce in its entire lifetime, You would see it, eventually, as its light crossed the intervening dark, but you would never hear it. The vacuum would swallow every sound, and the explosion would unfold in perfect silence. This is the true character of space. Not just empty, but silent. A stillness so complete that the most violent events in the cosmos take place without a whisper. The galaxies drift apart in silence. The stars ignite and fade in silence. The great voids swell in silence. The universe is the quietest place imaginable, a vast dark hall in which nearly everything happens and almost nothing is ever heard. And yet within our corner, the story of matter gathering against the emptiness is one of astonishing creativity. From the thin gas between the stars, gravity built suns. From the ashes of dying suns, the universe forged the heavier elements, carbon and oxygen and iron and gold. From clouds of that enriched gas, new stars formed, and around them, rocky worlds gathered out of the leftover dust. On at least one of those worlds, the elements arranged themselves into the delicate, self-sustaining chemistry we call life. And from life, over billions of years, arose complexity and awareness, and eventually a species capable of building telescopes and turning them on the sky. Every step in that chain was gravity and chemistry and time, working patiently against the emptiness, gathering the rare scattered matter of the cosmos into ever more intricate forms. The emptiness set the stage. But on that stage, in a few rare corners, something extraordinary unfolded. We should be honest about how little we still understand. We do not know what dark matter actually is, only that its gravity holds the galaxies together and shaped the cosmic web. We do not know what dark energy actually is, only that it fills empty space and drives the accelerating expansion. Together, these two mysteries make up 95% of the universe, and we can describe them only by their effects, not by their nature. We are like people who can see the wind only by watching the trees bend. The overwhelming majority of the cosmos is composed of things we cannot see, cannot touch, and cannot yet explain, hidden in the very emptiness we are trying to understand. The 5% we do understand, the ordinary matter of stars and planets and people, is the small illuminated portion of a far vaster and darker whole. The emptiness is not just the absence of things. It is the home of the greatest unsolved mysteries in all of science. There is a particular kind of vertigo that comes from truly grasping the scale of it. Our sun is one of 400 billion stars in the Milky Way. The Milky Way is one of perhaps 2 trillion galaxies in the observable universe. And the observable universe itself, the entire sphere of space from which light has had time to reach us since the beginning, may be only a tiny fraction of a far larger, perhaps infinite, whole. If you tried to count the stars in the observable universe at a rate of 1 every second, you would still be counting long after the sun itself had burned out. The numbers climb so high, so fast, that the human mind simply cannot hold them. And every one of those countless stars is separated from its neighbors by gulfs of emptiness so wide that light itself needs years to cross them. The cosmos is not merely large, it is large in a way that defeats every attempt to picture it, an emptiness so vast that the mind slides off its surface, unable to find any handhold at all. Perhaps this is why the emptiness feels frightening. It is not the fear of a monster or a predator, the old fears our ancestors knew. It is a deeper and stranger unease, the feeling of standing at the edge of something so vast that it makes everything human seem impossibly small. Against the scale of the cosmic voids, every mountain range is a grain of dust, every ocean a drop, every human life a flicker too brief to measure. The emptiness does not threaten us. It simply dwarfs us, so completely that our usual sense of importance dissolves in the face of it. And that dissolving can feel like falling, a vertigo of the spirit as much as the mind. But there is a curious gift hidden in that vertigo. For once we accept how small we are free to be amazed that we are anything at all. Faced with all of this, a person might reasonably ask what any of it means for a single human life. The cosmos is vast beyond comprehension, mostly empty, mostly dark, indifferent to our existence, destined in the deep future to fade into cold and silence. Against that backdrop, our brief lives on a small world can seem to shrink to insignificance. But there is another way to see it. The very same facts that make us small also make us extraordinary. In a universe that is almost entirely empty, matter that can think is vanishingly rare. In a cosmos that is almost entirely silent, a voice that can ask questions is precious beyond measure. We are not diminished by the emptiness. We are made remarkable by it, because we are the exception, the improbable pocket of warmth and awareness in an overwhelming dark. The meaning is not out there, written in the stars. The meaning is here, in the fact that something as unlikely as a conscious mind arose at all, and got the chance, for a little while, to look up and understand. We began by holding up a hand and feeling the fullness of a single breath. We end by understanding that the breath, the hand, the world, and every living thing upon it are an almost impossibly thin skin of matter stretched over an abyss of emptiness. The universe is empty for a reason. It is empty because it is old enough to have made us. It is empty because it is vast enough to have tried in countless places and succeeded here. It is empty because emptiness is the space in which time and gravity do their slow, patient work of turning starlight into thought. The emptiness is terrifying, yes, but it is also the reason there is anyone here to be terrified at all. Because here is the truth that survives even the coldest reading of the cosmos. In all that emptiness, awareness arose. Somewhere in the thin, bright web of matter, on at least one small world, the scattered atoms of dead stars gathered themselves into a form that could feel and think and wonder. The emptiness did not prevent this. In a strange way, the emptiness made it possible, by giving the universe the time and the room it needed to build such a thing. You are not separate from the cosmos. Looking in from outside, you are the cosmos, a small part of it that has, for a brief moment, woken up. The same emptiness that surrounds you also runs through you, in the vast spaces inside every atom of your body. You are made of the rare stuff and the empty stuff, both a pattern of matter and void that has learned, astonishingly, to know itself. And so we arrive, at the last, at something like gratitude. The cosmos owed us nothing. It did not have to produce stars or planets or the slow, patient chemistry of life or minds capable of wondering about any of it. It could have remained a thin, cold, expanding fog of particles, empty and dark and utterly without witness, forever. Instead, against odds we can barely calculate, it built galaxies and stars, forged the elements of life in stellar fire, and gathered them, in at least one small corner, into beings who could look up and understand. The emptiness that surrounds us is not a rebuke. It is the vast, quiet stage on which this improbable drama unfolded, and against which our own brief existence shines all the more brightly for being so rare. To be here at all, awake and aware in a universe that is mostly nothing, is an extraordinary piece of fortune. The emptiness makes it so, for without all that vast and patient dark, there would have been no time, and no room, and no us. Consider, too, how the emptiness shapes the search for other life. If the universe is teeming with living worlds, the great distances between the stars may keep them forever isolated from one another, each civilization an island unaware of the others. If life is rare, then the emptiness is even more complete. Vast stretches of cosmos with no awareness in them at all, no eyes to see the stars, no minds to wonder at the dark. Either way, the emptiness dominates. Even in the most optimistic estimates, living worlds would be scattered so thinly across the cosmos that the distances between them would dwarf everything. We have listened for signals from other civilizations, scanning the sky for any sign that we are not alone. So far, the silence has been complete. Whether that silence means we are truly alone, or merely that the emptiness is too vast for signals to easily cross, we cannot yet say. But the silence itself is a kind of answer, a reminder of just how empty and how quiet the cosmos truly is. So the next time you look up at the night sky and see it sprinkled with stars, remember what you are actually looking at. You are not seeing a crowded cosmos. You are seeing the rare bright threads of a web whose true substance is the dark between them. You are seeing the thin lace of matter that clings to the edges of an emptiness beyond all imagining. And you are seeing it with eyes made of stardust, in a universe that spent billions of years and unthinkable stretches of empty space, quietly assembling something that could look back. The emptiness made room for you. Take a breath. Feel how full it is. And remember that in all that vast and silent dark, against all the odds the cosmos could throw, here you are, awake, aware, and utterly, improbably alive. And still, against all of that emptiness and silence, here we are. On this one small world, the atoms of dead stars gathered themselves into oceans and continents, into forests and creatures, and at last into beings who could look up at the night sky and ask what it all means. We built instruments to measure the light of distant galaxies. We traced the expansion of space back to its beginning. We mapped the cosmic web and weighed the invisible dark matter and detected the accelerating push of dark energy. We, the temporary arrangement of stardust on a single small planet, came to understand the vast emptiness that surrounds us, an achievement so unlikely that it borders on the miraculous. The universe spent nearly 14 billion years and unimaginable stretches of empty space, building something that could comprehend it. And for a brief moment in cosmic time, on one small world, it succeeded. That is us. That is what we are. So when the emptiness frightens you, and it should, let it also amaze you. Let the vast, dark voids and the silent gulfs between the stars remind you not only of how small you are, but of how astonishing it is that you exist at all. The same emptiness that could swallow the earth without a ripple is the emptiness that gave the universe the time and the room to build you. The same silence that fills the space between the galaxies is the silence out of which your own awareness improbably arose. You are a rare and fleeting gathering of matter in a cosmos that is overwhelmingly empty. A small light that will shine for a little while and then return its atoms to the dark from which they came. That is not a tragedy. That is a gift, the rarest gift the universe has to give. The brief chance to be here, awake and aware, in a place that is mostly nothing. When you set this all down and return to your ordinary life, carry one thought with you. The universe is empty, overwhelmingly, almost perfectly empty, from the vast spaces inside every atom to the great voids between the galaxies. And that emptiness is not a flaw or an accident. It is the condition that made everything possible. The vast, quiet room in which time and gravity did their slow work of turning scattered starlight into worlds, and worlds into life, and life into a mind that could understand. You are the rarest kind of thing the cosmos produces, a small pocket of matter that has learned to know itself, shining briefly against an enormous dark. The emptiness will outlast you, as it outlasts everything. But for now, for this brief and precious while, you are here, awake and aware, gathered out of the dark into the light of a single fleeting life. And in a universe this empty, that is nothing short of a miracle.